So now here's now we're going to talk about planes in crystals. So for planes, we use, for a specific plane, we use parentheses, as shown at the top there. And so the important thing to note about planes is that, well, let's say we're going to work with 110 for a plane. Now, the normal, a plane is defined by its normal, basically. So the normal in this case is parallel to the direction of 110. And so this relationship between the normal of a crystallographic plane to just taking the index from the parentheses, this is only strictly true in cubic systems. In others, it may or may not be true, so just keep in mind about that. But since we're only today working with cubic systems, the normal to the plane is also just the index of the plane itself. So as an example, we can draw this out. So if I take the origin to be here, and I'm going to make x come down this direction, y here, and z going up. So I know that our normal direction is 110, so I'm just going to go plus x and plus y, and I'm going to come across this, the bottom plane there. So that's just going to be the direction 110. And since I also know that this is the normal to the plane, then you can just kind of schematically, visualize where that plane might be. And we'll go over more specifics about how to construct these more complex planes here in a second. So now this plane in green is our 110 plane. All right, so now for a family of planes, we use brackets. So you can say squiggly brackets, or just I call them brackets. So for a family of, say, let's go with 111 planes, I want you to take 30 seconds and write down all of the distinct planes using parentheses. So pause the video, take 30 seconds to do that. All right, so starting with the 111, so we're just going to write down the same plane for this. Now, what we can do is to kind of permutate where the negative sign is at. So we can just put the negative sign on the first one, we can put it on the second one, and then we can put it on the last one. And now maybe during that 30-second break, you wrote out some other planes. So the other possibilities are just making basically the negative of all these planes. And so that's basically just multiplying the indices by -1. But in reality, this is not, these planes that I'm writing out now in blue are not actually distinct and different from the previous ones, because they still actually define the same planes as before. So it's just that their normal is in a different direction. So in reality, there's only 4 111 planes, and they are given in red or in blue. You can choose, which convention to use there. So for the family of 111 planes, there are only 4. And so if you have questions about that, feel free to ask me on Friday when I'm back. Excuse me. All right, so now we're going to go into a little bit more detail on actually drawing the planes. So the step to draw a more complex plane is to first take the reciprocal of all of the HKL, the Miller indices, and then to mark the axis intercepts and connect the points, connect the dots. So let's start off with a slightly complicated one. So we're going to try to draw the plane 1, 2, 3. And so to start off with, what we're going to have to do is draw the origin. And we're going to choose the origin and draw in your coordinate system. So x, y, and z. So the first step is to take the inverse of all of the indices. So step 1. So 1 over 1, 1 over 2, and 1 over 3. So what this means is that the plane crosses the x-axis at 1, the plane crosses the y-axis at 1/2, and the plane crosses the z-axis at 1/3. So this method is, you can use this pretty easily, and I'll show you some more complicated planes later on, and we'll go through solving those. So in the first case, I'm just going to draw the dot for where it crosses the x-axis at 1, draw the dot for where it crosses the y-axis at 1/2, and then finally at 1/3 for z. And then you just connect the dots, as I said before, and boom, there's your 1, 2, 3 plane. And so remember again that the normal in the cubic systems is given by also the Miller indices. So you can also say that this direction, even though you can't really visualize it like this, but its normal direction is parallel to the 1, 2, 3 direction. So let's do an example of doing the inverse. So here I'm showing a plane that's already drawn in red on the right hand side. And so let's try to figure out what that specific plane is. Well, again, you can probably inspect it and see that it's a 1, 1, 0 type plane. But what we have to do though is draw in the origin. So I'm choosing the same origin as before, so x, y, and z. And so we're just going to work through the same steps as before, but just go in reverse. So the first thing that we're going to do is record where the plane intercepts all the axes. So for x, y, and z. So for x, where does it intercept the x-axis? It doesn't, so it's 0. For y, where does it intercept? It intercepts at 1, and for z, it intercepts at 1 as well. So then we're going to invert the indices, and it's just going to be 1 over 1, and 1 over 1. So we're left with the plane, the specific plane 0, 1, 1. So that's how you go through the process of, seeing it and then figuring out the specific plane.